Alright everybody, so today we're talking about the remainder theorem. So it says a polynomial f of x is divided by x minus k, then the remainder is f of k, or basically if you just plug k into the equation, then the y value that you get out is the remainder. This means, which I literally just said that, this means that the answer when you plug k into the function is the same as the remainder. Alright, so this is probably the key thing that you want to take away from the remainder theorem. The factor theorem says a polynomial f of x has a factor x minus k if and only if the remainder is equal to 0. This means if you plug k in and you get out 0, then x minus k is a factor. So this says use the remainder theorem to find the remainder when x cubed minus 14x plus 8 is divided by x plus 4. It says do not do any divisional work, use the remainder theorem. Well, the remainder theorem says if I just plug in the solution of x plus 4 into here, then I would get out the remainder. So that's going to be negative 4, so I'm going to say f of negative 4 is equal to negative 4 cubed minus 14 times negative 4 plus 8. So negative 4 cubed is negative 64. Negative 14 times negative 4 is positive 56. And then plus 8. 56 plus 8 is going to give us 64. So negative 64 plus 64 is equal to 0. So our remainder of that division problem is 0. If x minus k is a factor of a polynomial, then what is k called? Has a lot of different names. It can be called a solution, could be called a root, could be called a 0, could be called an x-intercept. Right, those are all of our different names for what k could be if x minus k is a factor. It says use synthetic division to divide x cubed minus 14x plus 8 by x plus 4. Don't forget 0 in your setup. So the negative 4 goes on the outside. On the inside goes all of the coefficients. So 1, 0, negative 14, positive 8. Drop the 1. Negative 4 times 1 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 4 is positive 16, which that gives us 2. Negative 4 times 2 is negative 8, which gives us 0. All right? So the answer then, remainder constant x squared, would be x squared minus 4x plus 2. Was your remainder what you thought it would be according to number 2? Yes, right? In number 2, we got a remainder of 0. In the problem we just did for division, we got the same exact remainder of 0. So based on our understanding of long and synthetic division and how to find zeros and factors, these next questions represent different ways that I could ask you to do these things and different ways I can give you information. So in all of these questions, you're going to need to use synthetic division to help you solve. So the first question says factor. All right, it's saying factor f of x equals 2x cubed plus 11x squared plus 18x plus 9 if f of negative 3 is equal to 0. So this is telling us that negative 3 is a 0 of this function. How does that help us with factoring? Well, it physically tells us that x plus 3 is a factor. And we know that because x minus k from our remainder theorem, okay? Because f of k is equal to 0. All right, so what do you need to do to find the rest of the factors? Well, we actually can't factor this in its current state. So what we need to do is divide that function by x plus 3. So then we're going to put negative 3 on the outside. Synthetic division goes 2, 11, 18, and 9. Drop the 2, you get negative 6. Negative 6 plus 11 is 5. Negative 3 times 5 is negative 15. 18 plus negative 15 gives us positive 3. Negative 3 times positive 3 gives us negative 9, which then gives us a remainder of 0, which was the expectation because of this. But how does that help us? We have this new equation that's an x squared function. It's 2x squared plus 5x plus 3. And then this should hopefully be factorable. So we have 2x and x. If you go, we have positive 3. So if we go positive 3 here, positive 1 there, that would be 2x. This would be 3x. That would make 5x. Yeah, so those are our other two factors. So if we're factoring that polynomial completely, it would be 2x plus 3 times x plus 1 times that initial one that we wrote, x plus 3. All right? So then if you multiplied all of this out, you would get out this polynomial back. And that is the perfect way to check these solutions. If you just want to be with a really quick check, you just say, okay, there's 1x, 2x, 3x's. That's going to make 2x cubed. Okay? All right. On to number 5. It says 1, 0 of f of x equals x cubed plus 11x squared minus 150x minus 1,512 is x equals negative 14. Find the other zeros of this function. Again, this is exactly like the last question. The last question told us negative 3 was a 0. This question is now telling us negative 14 is a 0. So that tells us x plus 14 is a factor. All right, so if we know x plus 14 is a factor, we can divide this polynomial by x plus 14 to get it into an x squared polynomial that hopefully is a little bit more straightforward to factor. All right, so let's do exactly that. We do synthetic division to set this up because synthetic division is the easiest way to divide in my opinion. But if you like long division, by all means, long division can be your friend here. So you go 1, 11, negative 150, negative 1,512. Drop 1 and you get positive 1 here. Multiply by negative 14. You add those and you get negative 3. Multiplied by negative 14 gives you 42 here. Negative 150 plus 42 is negative 108. Negative 14 times negative 108 actually gives you 1,512. So there's our remainder of 0. So again, we have remainder, constant, x, and x squared. So that gives us x squared minus 3x minus 108. All right, so now we need factors of 108 that are going to make negative 3 in the middle. So we got x and x. We have plus and minus. 12. 108 divided by 12 gives you 9, which we need 3. 12 and 9 is 3. So we need negative 12 and positive 9. Awesome. So those are the factors. And then we have x plus 14. And the question was find the other zeros. So all of the zeros would be negative 9, positive 12, and negative 14. Sweet. Next one says one factor of f of x, x squared minus 2x, x cubed minus 2x squared minus 40x minus 64 is x minus 8. It says find the other factors to factor the polynomial completely. All right, this one is a little bit more straightforward. It's almost telling us that we need to divide this by x minus 8. So let's do precisely that. If we take out our synthetic, it's going to be 8 on the outside, 1, negative 2, negative 40, and negative 64 on the inside. Drop the 1 to get 8. Sorry, drop the 1 to get 1. 8 times 1 is 8. Negative 2 and 8 is going to be positive 6. 6 and 8 is going to be 48, which would give us positive 8 again. 8 times 8 gives us 64, which gives us that remainder of 0, which again is always expected because we know that x minus 8 is a factor, so it shouldn't have a remainder. Remainder, constant x squared, so that's x squared plus 6x plus 8. Factors here are going to be 4 and 2, so positive 4, positive 2. And then that original factor of x minus 8. All right, so those would be all of the factors of that polynomial. Awesome. Okay, number 7. It says the volume in cubic inches of a box can be expressed as the product of the lengths of its side. That's our equation. The volume of x is equal to x squared plus, or x cubed plus x squared minus 12x. It says write the linear expression for the box's length and height, given that the linear expression for the width is x minus 3. Note, the length is larger than the height. So, we know that one of the factors is x minus 3. So that's where we're going to start. Positive 3 on the outside. 1, 1, negative 12. And then the last thing is 0, right? That's x cubed, x squared, x, and our constant term of 0. So then we drop the 1. You get 1. 3 times 1 is 3. 1 plus 3 is 4. 4 times 3 is 12. 0, 0, 0. So we have remainder, constant x, and x squared. So that gives us x squared plus 4x. And then really it's just plus 0. So then the factors of this are x and x plus 4. It says write the linear expression for the box's length and height. So the length, it says the length is larger, is equal to x plus 4, and the height is equal to x, because x plus 4 is going to be bigger than x. Awesome. Okay, last one. So the last one says find k so that when x cubed minus kx squared plus 6x plus 12k is divided by x plus 2, the remainder will be 0. Okay, so this is kind of a crazy one, but what we're going to do is we're physically just going to put that k into our synthetic division. Negative 2 goes on the outside. We have 1, negative k, 6, and then 12k. And then we're just going to do synthetic division. So you drop the 1. Negative 2 times 1 is negative 2. This is addition, so it's negative 2 plus, or just minus k, so plus negative k. And then you're going to multiply that whole thing by negative 2. So that's going to be 4 plus 2k. So 6 plus 4 plus 2k is 10 plus 2k. Multiply that whole thing by negative 2. We now have negative 20 minus 4k. And then 12k plus negative 4k tells us negative 20. And then that's going to be plus 8k. All right. And so we want this negative 20 plus 8k to be equal to 0. Because we want this part, which is the remainder, because remainder, constant, x squared. We want the remainder to be 0. So we're going to go negative 20 plus 8k is equal to 0. Add 20 to both sides, and you get 8k is equal to 0. Or is equal to 20. Sorry, not 0. Divide both sides by 8. You get k is equal to 28ths, or if you divide both of those by what, 4 is the biggest number, you get 5 halves. So the k value that makes this remainder 0 is 5 halves. So number 8, probably the craziest out of all of them, right? But yeah, that is some applications of polynomial division. If you have any questions, please feel free to message me on Canvas. I know that this stuff might have been a little bit confusing, so just let me know what you have. Have a great day, guys.